Welcome to Math Zone African Motives. Today, we're diving into Module 4 to explore the exciting world of exponential graphs. By the end of this tutorial, you will be able to identify the key features of an exponential graph and, most importantly, sketch any exponential graph by following a few simple steps. Let's get started. First, let's understand the fundamental shape of an exponential graph. There are two general forms we'll focus on. On the left, we have the general form y equals k times a to the power of nx, where a is greater than 1. Let's break that down. A is the base of the exponent. When this base a is a number larger than 1, like 2 or e, the graph has a specific shape. It's an upward curving graph, starting near the x-axis for negative values of x, passing through the y-axis, and then growing very quickly as x increases. This is what we call an increasing exponential function. The graph shows rapid growth. Now let's look at the second general form. On the right, we have y equals k times a to the power of nx. But this time, the base a is a fraction or decimal between 0 and 1. For example, a could be 1/2. This gives us a different shape. It's a downward curving graph, starting high on the y-axis for negative x values, passing through the y-axis, and then approaching the x-axis as x increases. This is a decreasing exponential function. You can think of this as exponential decay, where the value of y shrinks as x grows. So, the key takeaway here is, a base greater than 1 means an increasing graph, and a base between 0 and 1 means a decreasing graph. Both of these forms share some important features that are common to all exponential graphs. Let's go through them. First, the graph is a function. This means that for every single input value of x, there is only one output value of y. You can verify this using the vertical line test. Second, the graph is continuous. This simply means you can draw the entire curve without lifting your pen from the paper. There are no breaks, jumps, or holes in the graph. Third, the graph is not symmetrical about either the x or y-axis. Unlike some other functions we've seen, an exponential graph doesn't look like a mirror image on either side of the axis. Fourth, let's talk about the domain and range. The domain is the set of all possible input values. For any exponential function, you can substitute any real number for x and get a valid answer. So, the domain is all real numbers, which we write as x is an element of R. Fifth, the range is the set of all possible output values. You notice how the graphs we drew never touch or cross the x-axis. The y value is always positive. This is a key characteristic. The range is the set of all positive real numbers, which we write as y is greater than 0. Sixth, the graph has an inverse function. We won't be sketching the inverse today, but it's important to know it exists. The inverse of an exponential function is a logarithmic function. Now that we have the theory, let's put it into practice. We're going to work through example 412, sketching 4 different exponential graphs. Here are the 4 equations we will be sketching today. We'll take them one by one. Let's start with the first one. Our first equation is y equals 4 times 2 to the power of x. A great way to sketch any graph is to find some key points. For an exponential graph, finding the y-intercept is always a good start. The y-intercept is where the graph crosses the y-axis, which happens when x equals 0. So we substitute x equals 0 into our equation. This gives us y equals 4 times 2 to the power of 0. Remember, any non-zero number raised to the power of 0 is 1, so 2 to the 0 power is 1. This simplifies to y equals 4, so our graph crosses the y-axis at the point 0, 4. Next, let's determine the shape. Look at the base of the exponent. It's 2. The base a is 2. Since 2 is greater than 1, we know this will be an increasing exponential graph. This means it will go upwards from left to right. Now we have enough information to sketch the graph. First, draw your x and y axes. Then mark our y-intercept at the point 0, 4. Finally, draw a smooth, increasing curve that passes through this point and approaches the x-axis as x gets smaller. Label the graph with its equation. And there you have it. Comparing our sketch to the solution in the textbook, we see it's a perfect match. The method of finding the y-intercept and checking the base works every time. Let's move on to the second equation. This one is y equals 3 times e to the power of x. Again, let's find the y-intercept by setting x equals 0. We have y equals 3 times e to the power of 0. And again, anything to the power of 0 is 1. So e to the 0 is 1. This gives us y equals 3. So our y-intercept is at the point 0, 3. Now for the shape. The base this time is the number e. The base a is e. The value of e is approximately 2.718. Since 2.718 is greater than 1, we know this graph will also be an increasing exponential function. We have our intercept and our shape. Time to sketch. Draw your axes. Mark the y-intercept at arrow 3. Then draw a smooth increasing curve through that point, approaching the x-axis on the left. Finally, label the curve with its equation. As you can see, this is the exact same result as the one in the textbook. On to the third problem, and this one has a small twist. We need to sketch y equals 3 to the power of negative x. Let's first find the y-intercept by setting x equals 0. Substituting x equals 0 gives us y equals 3 to the power of negative 0, which is just 3 to the power of 0. And 3 to the power of 0 is 1, so our y-intercept is at the point 0, 1. Now let's look at the shape. The base appears to be 3, but we must be careful. The exponent is negative x. Here's the rule for negative exponents. A to the power of negative n is the same as 1 over a to the power of n. Let's apply this to our equation. Y equals 3 to the power of negative x can be rewritten as y equals 1 over 3, all to the power of x. Now we can clearly see the base a. It is 1/3. Since 1/3 is a number between 0 and 1, we know this graph is a decreasing exponential function. This means it will go downwards from left to right. We have our intercept and our shape. Let's sketch it. Draw your axes. Mark the y-intercept at 0, 1. Then, draw a smooth, decreasing curve that passes through this point, approaching the x-axis as x gets larger. Label the graph. Notice how the textbook solution also wrote the rewritten form of the equation. Our sketch matches perfectly. Finally, let's tackle the last graph. This one is y equals 2 times the quantity 1/5, all to the power of x. We follow the same process. First, the y-intercept at x equals 0. Substituting x equals 0 gives us y equals 2 times 1/5 to the power of 0. Again, any non-zero number to the power of 0 is 1, so 1/5 to the power of 0 is 1. This means y equals 2, so our y-intercept is at the point arrow 2. Now for the shape. The base of the exponent is clearly 1/5. The base a is 1/5. Since 1/5 is between 0 and 1, we know this graph will be a decreasing exponential function. With our intercept and shape known, we can sketch the final graph. Draw your axes. Mark the y-intercept at 0, 2. Draw a smooth, decreasing curve through this point, approaching the x-axis on the right side. And finally, label it with its equation. Just like the other examples, our result matches the textbook solution perfectly. The method is consistent and reliable. Let's quickly recap what we've learned today. We covered the two main forms of exponential graphs. The increasing type, where the base a is greater than 1, and the decreasing type, where the base a is between 0 and 1. We also identified the key features common to all exponential functions, such as their domain being all real numbers and their range being all positive real numbers. Most importantly, we've established a simple and effective strategy for sketching these graphs. Find the y-intercept by setting x to 0, then look at the base to determine the shape of the curve. With these two pieces of information, you can sketch any basic exponential graph. This concludes our tutorial on sketching exponential graphs. You are now equipped to handle these functions with confidence. Thank you for watching. Subscribe for more tutorials from Math Zone African Motives to continue your learning journey.